We're going to address the digital challenge application video. This is the website for Digital Challenge. You can see they have a lot of different applications, and the one we're interested in this class is Digital Challenge app. These other applications are used in other courses in electrical and instrumentation. Very good tutorials. We go to this page and we can see the applications listed again. Again, Digital Challenge. And we have a selection to choose from. Trial, download. There's a 2-week free trial for all these products, after which you have to put in the key. And when you click on this, you can then download this to any place you want to on your computer. It's an application, so then you'll need to set up the application by running the installation program, which is what you're downloading. So you can save that and run it, and that's how you acquire the program. Now, having done that already, here is the icon you'll see on your desktop whenever you download and install the program. And then when you run the program, you're going to see this. In fact, I'm going to go back a step because you actually won't see that. Let's double click here. The application begins. It's loading the program. It fills the entire screen. And when you look at this, you can see that there's a chance for you to put in the license. Now, if you're doing the assignments, if you're doing the step-by-step programmatic learning in this Blackboard course, then you will see in one of the steps a document that you are to click on, which shows you this key. And then when you have that key, you can choose appropriately. If it's 3-line, choose the 3-line, or 2-line, choose the 2-line. And then once you do that, you unlock the software. In my estimation, I believe it's a 3-line. And you have to put that in exactly. Already one student said that they tried it 10 times and it just doesn't unlock the software. So I suggested to the student cut and paste off the document, and then it's going to work, because in keys, you have to have everything typed exactly right. Punctuation, spaces, upper, lowercase. Now here you have to put in your name. And you have to, because if you want credit for doing these, and this is a third of your grade, I think, you need to have your name on the certificates when you upload them. So I put my name in. Now, another problem we're going to solve here is the fact that essentially the application takes over the screen. So go to Options and click on this button, this check mark, and uncheck Display Wallpaper, and you notice now you can see everything. So let's continue. Here's where you can put in the license key. Again, it's a 3-line key. You don't need it for 2 weeks. Now we're looking at the program itself, and you can see there's many things to choose. The idea would be in any program to do the initial settings, and we already went there in another way, and you can see a lot of things you can do. We're not going to worry about storing on the disk or printing certificates. You could edit your name if you need to. Let's go back. The reason we're not going to store or print is because you're going to learn a new technology using a tool called Snip and Sketch. And here at the bottom, you can see Snip and Sketch on my tray. you get there. It's built into Windows, so it's nothing you have to buy either. And you simply type in snip. And you'll probably run into two, like I did, Snipping Tool and Snip and Sketch. Snipping Tool is older. Snip and Sketch is newer version of Snipping Tool. So you have a choice here to add it to your tray. I suggest you do that so you can quickly get to it like I am doing. So I'm going back down here. I'm going to click on the icon. Either of those applications will do. Snipping Tool just has a little less versatility. Now what you have with Snip and Sketch is an enhanced screen capture. And let's just practice it. I'll drag it over here and click on New. And once it starts, it's going to let me choose whatever I want to capture as an image. And for example, if I want to just capture this is not something you need to do. Just demonstrating. Now it'll pop back up and show you that that's exactly what you chose to capture. And we're going to use this for uploading certificates into Blackboard. So I'm going to go ahead and cancel Snip and Sketch for now. Next thing I want to do is talk about this button, Introduction. And you know, it's smart to read introductory material. Many of us don't. There's the program purpose. Here's the program operations. In case you have any problems, it tells you how to use the program. You don't need me to tell you. And now I'm going to quit. Oh, before I do, notice there's two tabs. In some of these programs, you'll see multiple tabs, and the idea before you take the exam is to look at everything on every tab. I don't think that's really an issue in this particular ETCAI application digital challenge. Now I'm going back to the main screen, and here I want to call to your attention these different modules. We're going to go through these that have the light bulbs are shaded in yellow, and they're going to be sequentially done. They do stair step like my course. I'm not the only person using that idea. Stair stepping, so you learn and continue with the tools you learned in the previous step. So start with binary, go to octal, hexadecimal, keep going down to logic gates 1. And then when you finish that one, go up to the next column to logic gates 2 and continue until you get to simplification. And that's all we're going to do. We're not going to do these last 4. This is a method of giving to students in tech studies a basic and super basic foundational understanding of digital electronics. Actually, not so much electronics as digital technology. Binary, base 2 is what it's all about. And the reason for that is computers are calculators. You may not realize that. They only know how to calculate and do math, and all the rest of it is amazing. How what you see, even in this tutorial, is all based on calculator called a computer. And that computer only calculates in one number system. It's binary, and it doesn't understand decimal. It doesn't understand the letter K. It doesn't understand a word. It is only capable of calculating. And so we, if we're going to talk to a computer, need to understand how they think, and they think through calculations. It's a glorified calculator, and it only does base 2. So that then means it really is handy for any student of computer technology, including PLCs, to get an understanding of basic digital. And this is where we're providing that in your curriculum. So the first tutorial is binary counting, and I'm going to go into that. What you expect to see when you click on any of those buttons is a short tutorial teaching you the lesson. Now, this is technical writing, and you're a technician, and your job is to understand this. not say I need help. Now, certainly we all need help from time to time, but the first tactic is to take it on yourself, own it, conquer it, and then test yourself on it. And what I'm doing now is I'm looking at, there's a heading, binary counting. Here's some information. There's a illustration, another one over here, and then some more information. There's no tabs. So this is it. In every one of the tutorials, once you have understood this to the best of your ability, then you can click on this begin button, which begins an examination leading to a certificate which you will upload with your grade. I have allowed multiple uploads in Blackboard, so if you make a 78 the first time, my concept is to encourage you to not accept that as what you want for a grade, because this does lead to part of your composite grade in the course. But go back and take it again and get a 93. And if that's still not good enough, do this activity again and get 100. There's no reason, except for your decision, for you not to make 100 on every one of these. So now let's learn binary counting. Binary numbers are represented using only 2 digits, ones and zeros. There are a number of ways to learn binary counting. One simple way is to learn the column values. So here I'm seeing columns. The right-hand column of a binary number is the ones column. That would be this one right here. The next to the left is the twos column. The column values double as we move to the left. Column values are assigned as shown in the diagram below. So what they verbally said, now they're showing in a diagram. And you notice progression, even though they're saying start here on the right and go to the left, they're doing a little right angle turn to tell you what each of those columns represent. So this is 1, 2, 4, 8, 16, 32, 64. And they don't really make it clear, but those are all powers of 2. Any number to the 0 power is 1. Any number to the first power is that number. So 2 to the first power is 2. And then from there, it's pretty handy and easy to understand. 2 to the second power is 2 times 2, so that's 4. 2 to the third power is 2 times 2 times 2, often called 2 cubed, and that's 8. So look, as we do the powers progressively, these numbers actually double. 1, 2, 4, 8, 16, 32, 64. 2 to the 0, 2 to the first, 2 squared, 2 cubed, 2 to the fourth, 2 to the fifth, and 2 to the sixth. Those are very interesting numbers because you may have heard of some of these numbers when you're dealing with computer electronics. Now, the next thing they really didn't go into is this conversion they're showing you. And again, this is where you as a technician need to concentrate and study and decipher this mystery. Where did these numbers in yellow come from? Well, they're showing you that 1, you use these, this is a binary number. It's all ones and zeros. It fits the rule right up here, 2 digits, and those are ones and zeros. There are no other numbers, no 2s, 3s, 4s. So we're limited. But here they give you an example binary number. This could be a base 10 number, and we're going to notice that in another tutorial how we can notate so you know this is not base 10, because base 10, base 8 has ones and zeros as well. But they're indicating this is a binary number, and they're changing it to a decimal number by this technique. And even though this is not what the lesson is about, they're giving you extra information. The lesson's about binary counting, which is really this diagram. But let's understand this. If I take 1 and multiply it by this number, written verbally, 1 times 1 is 1. 1 times 2 is 2. 0 times 4 is 0. 1 times 8 is 8. 1 times 16 is 16. 0 times 32 is 0. And 1 times 64 is 64. And the next step for converting this binary number to a decimal number, the ones we understand, is simply to add these numbers, and it sums up to 91. So if I have the binary number 1011011, and that is in base 2, the base 10 version is 91. That gives you a good ability to see equivalence in different number systems. And there's many number systems. In this course, we'll be concentrating on base 2, base 8, base 10, and base 16. And that is to say, we'll be concentrating on decimal, which is base 10, octal, which is base 8, hexadecimal, which is base 16, and binary, digital. That's the complementary word, digital, not binary, which is base 2. That term comes from digit, which is a finger. So either you have a finger or you don't have a finger, and it's very simple mathematics. The base 10 equivalent of the number above is 91 because the number contains a 1, a 2, a 0, no 4s, an 8, a 16, no 32s, and a 64. Another example, the binary equivalent of the base 10 number 19 equals 10011 because 19 contains a 16, that would be this one, no 8, no 4, a 2, and a 1. Now, look, they're taking this another step forward. This one, they're saying 19 is equal to this binary number. How did you get there? And let's look at it another way. If this is 1, 2, 4, 8, 16, 32, and 64, which of these, starting with the lowest one, adds up to be 19? 1 plus 2 is 3. If I add 4, that's 7. Can I add 8? Yeah, that's 15. But I can't add 16. So this is basically 1, 2, 4, 8, 16. So to get 19, that way didn't work, but what do I do? What's the highest number here that I can pull out of 19? And the answer is 16. So put a 1 for 16. Next question, what do I have left over? 19 minus 16 is 3. Okay, what's the next highest number of these can I pull out of 3? Well, I can't pull out 8 because 3 is smaller, so I put a 0 here. I also cannot pull out 4 because 3 is smaller, so I put a 0 here. I can pull out 2 from 3, so I put a 1 here. And then I have 3 minus 2 is 1. Last question, which of these can I pull out of 1? Only 1, so I put a 1 here. And that's how you get it. Now, one more way to look at this, I can look at this binary number and remember, starting from the right, going to the left, double 1, 2, 4, 8, 16. So the ones mean I use those. So 1, 2, I use both of those, that's 3. I don't use this one or this one, but I use a 16. 16 plus 3 is 19. Over here is really unaddressed, but the whole concept of binary addition. Now they have 4 columns because binary increments rather quickly, and you'll see it as we examine this. So in blue is base 10, what we're normally used to, and here we have the binary equivalent. So when we count, we always just add 1 and then come up with the next number. So let's count in decimal. 0 plus 1 is 1. 1 plus 1 is 2. 2 plus 1 is 3. 3 plus 1 is 4. 4 plus 1 is 5, all the way down to 31. And we don't really count by saying plus 1. We just do it mentally. So we say 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now on binary, we do the same thing, but we run out of numbers really, really quick. We only have 2 numbers. So then we have to learn about this whole concept of what do you do when you run out of numbers? Now, what did we do in base 10 when we ran out of numbers? If you count the number of symbols between 0 and 9, there are 10. So I'll have to say we were taught a little bit biased on how to count, because mamas and dads taught us to start with 0 and start counting upward. No, they didn't. They said start with 1, and that's peculiar. Look, Mr. 0 up here feels left out. He says, I'm about a number. Why did you skip me? So when we learned to count with our fingers 1 to 10, we actually went into that 1, 0, 10, and it wasn't really part of the sequence of individual numbers in base 10. It's actually 2 numbers, the 1 and the 0. That's what 10 is. But 0 through 9 are 10 symbols that we use for base 10. So getting back to this, what happens when we add 1 to 8? Well, when we add 1 to 8, we get 9. Now here's the magical part. What happens when we add 1 to 9? There's no more numbers. So this 0 in so-called 10 is where you're starting the sequence over. The sequence is 0 through 9. So we notate that, and then we put down a tally mark to the left of it that tells us how many times we went through this sequence already. Well, as we counted from 0 to 9, we finished the sequence. So we put down a start of the next sequencing. And then this 1 means that we did it the first time. So there's the definition of 10. It's not a separate number. It's a mathematical convention for us to deal with running out of numbers. And here we can then, we already know, just add 1 to increment. And then we get down to 1, 9, and there are no more numbers in the sequence. We went through this 0 to 9 once again. We have the 1 to the left reminding us we had done it once before, but now we've done it twice. And guess what? We start the sequence over and put down 2 to remind us we've already been through the sequence once and we're about to do that sequence once again. And that's the nature of these double-digit numbers. Now, you can say it, you can look at it any way you want to. You were taught that after 9 comes 10, but more information has been given to you. And you can see that this is going to help us a whole lot to keep track with how many apples we're counting. Now, with base 2, binary, digital, we run out of numbers a lot faster. So we have to use this whole convention a lot sooner about how to deal with starting over. So 0 plus 1 is 1, but 1 plus 1, there's a problem. There is no 2. And we've just run out of numbers. So look what happens. We put a 0 down here to start the 0, 1 sequence again, and we put a tally mark to the left to say, oh, we have already done it once. Those tally marks are handy to keep track with what has gone before. So now what do? Well, 1, 0 plus 1 is 1, 1. But when we add 1, 1 plus 1, we have no 2. So guess what we have to do suddenly again? 1 plus 1 is 0, and add a tally mark. Well, adding tally marks now, that's 1 plus 1 again, so it's 0, and add a tally mark. And for convenience, whenever we do this, you may start to think about how you learned about carrying when you add. 9 plus 1 is 0, carry the 1. 19 plus 1 is 0, carry the 1. Added to the previous one, you got 2, 0. On this one, 1, 0 plus 1 is 1, 1. 1, 1 plus 1 is 1 plus 1 is 0, carry the 1. 1 plus 1 is 0, carry the 1, bring the 1 down. And this is something you're going to probably have to study. It seems that sometimes the very simple things are the hardest to grasp, and yet this is what you're called on to do. So let's go over here and begin. Now we have a little chance to have a test. Here we go. 100 is where it starts for this series of test questions. Column 2 is different and column 3 is different. They have a different starting number. So what's 100 plus 1, or 100 plus 1? Well, 101. Well, if we add 1 to 101, we have this problem with 1 plus 1. So we're already having to carry. 1 plus 1 is 0, carry the 1. That would be above the second column. Bring that 1 down because 1 plus 0 is 1. And leave this one alone because nothing got that far. Now, every other step is going to be pretty simple in binary, and the next one's going to be a little challenging. Ordinary, what skills you already have, 1, 1, 0 plus 1, 1, 1, 1. Next one is challenging. 1 plus 1 is 0, carry the 1. 1 plus this 1 is 0, put it down, carry the 1. 1 plus this 1 is 0, carry the 1 and bring the 1 down. So after this is 1, 0, 0, 0. And you'll just continue on until you get to the bottom. 1, 0, 0, 1. 1, 0, 1, 0. 1, 0, 1, 1. 1, 1, 0, 0. 1, 1, 0, 1. And 1, 1, 1, 0. With practice, you'll get this. 1, 0, 1, 1. Oh, look, it was right here. There's a little critical thinking. But if I add 1 to that, it's 1, 1, 0, 0. 1, 1, 0, 1. Easy. 1, 1, 1, 0. Hard. 1, 1, 1, 1. Easy. Now the hard one. Well, look. When I added 1 to these 3, I end up with 4 numbers with a 1 on the left. Adding 1 to these 4 numbers, I end up with 5 numbers with a 1 on the left. Or you can do the math. 1 plus 1 is 0, carry the 1. 1 plus 1 is 0, carry the 1. 1 plus 1 is 0, carry the 1. 1 plus 1 is 0, carry the 1, bring it down. Now, after you finish start grading, it's asking you if I'm sure. Yeah, I got them right so far. Thank goodness. Oh, I gave out. I got tired. I didn't finish, so my grade will suffer. Over here on the bottom left, a little window popped up. Exercise complete. Select OK to continue. Skip disk storage. And here's my certificate. Remember our snip and sketch? Come down here, invoke it, slide it over, click on new, pause, here it comes. Here's my record. Now I held down the mouse cursor here until I got here, let go, and now here's an image of that. Notice I have my name here for credit. I've got my score. The rest of this stuff you can ignore. And what am I going to do now? Well, in a previous tutorial, I mentioned how to set up the structure for the directory of keeping your assignments in order. over here, I have a setup per the directions I taught you. When I double click on there, this will be in OneDrive for y'all. Same format happens. You just go to OneDrive and start it and find the ELPT 2319 directory you created. And then you'll have these three folders inside the ELPT 2319 folder. We're going to put this certificate in the digital challenge folder. And you can see I've already got one in here. Well, just for fun, let's erase the evidence that that was ever there. Boom, it's gone. Because now I'm going to put a new one in there. Right here is my image. And this icon is kind of an interesting icon to use nowadays because the floppy disk is legacy, is no longer around. But click on it. And notice the name is binary counting. Click on this. And it's going to let me save this. I'm going to change the name screenshot to binary counting. This is useful for you when you're keeping these records for uploading later. And you see, I changed the name, but now it lets me choose where I'm going to put it. You could go to OneDrive, certainly, and it works just the same. Here's my OneDrive. I'm not going to go there actually, but I notice that this is the PC I'm on, the desktop, and here's the folder that I showed you earlier. I'm going to double click on it. Lets me enter into the folder. I'm going to double click on Digital Challenge. Here's the empty folder, and I've got the right file name. I'll click Save. Now, after doing that, I can get rid of this, snip and sketch. And you can see now the new one is here. I just saved. It's double clicking to be sure. Not a problem. There it is, my name, 50%, this date and time. Okay, so now in this folder, you have this assignment. Keep all your digital challenge certificates in here by name. So when you get to the Blackboard Upload Center, you can easily find the right one to upload, no mistakes. The other thing I want to say about this digital challenge is that you do not print. Yes. You can proceed and go through these. You don't have to wait for them to show up in Blackboard to upload them. If you get on a roll, sometimes continuous learning is helpful. Just go to the next one and the next one and the next one until you get tired. If you go through simplification, you've learned a lot and kept your certificates in that folder. So throughout the course, whenever it says upload one, you've already got it done. You may want to just wait and do them one at a time as they appear in the course, but eventually you'll have a place to upload all of these. So nothing preventing you from continuing and making progress outside Blackboard on the digital challenge. And you do everything exactly the same way. Click on the next one. It's octal counting. It's like binary counting, but a little bit of a twist. And this concludes the tutorial on the digital challenge and how to do the individual binary counting exercise. Okay, so now we'll go back to Blackboard, and I'm going to end the recording. Y'all have a good